This is exercise 316. For this, they give you two different figures, and I'm going to kind of do A, B, and C all together, um, and so they might be a little scattered. Okay. We're going to start with A. Is the correlation R for the data in K4 near -1, clearly negative but not near -1, near 0, or clearly positive but not near 1, or near 1. So out of all of those situations, I would look here and I would say that it is clearly positive but not near 1. It does show that as IQ score increases, the GPA increases, but it's not a super strong because you've got some of these outliers here that are already that kind of mess up the graph. Okay, so that's why it's not quite exactly clear positive. There's a lot of variation in this pattern. For part B, uh, we say is it closer to 1 than that for either 3.4 or closer to 0. In this one, notice it's very much, you can still see that pattern. Even stronger, you can see that as the number of calories increase, the sodium increases. So this one is closer to 1 because it makes an even better relationship. Now, C asks us that both of those contain outliers. See, like there's an outlier here and here and here, and then there's an outlier here. If I were to remove those um, in figure 3.4, would R increase or decrease? Uh, Definitely in 3.4, R would increase. Because when we get rid of these outliers, it makes it even stronger. It gets rid of that ambiguousness and it makes the positive relationship even more believable. And 3.8, if I remove this part, then notice that's a very, even though it is an outlier, it still fits our model, right? Then as calories get smaller, the sodium gets smaller, and so it does fit. So actually, if we get rid of that outlier, R would decrease because it we'd have a little bit more variation in terms of whether things actually do increase or decrease, basically. This forces it to be very positive and to have that close relationship. But without this point here, it's not quite as strong.